Welcome to Lesson 20, the one where you finally learn why some PCs feel instant and others feel like they're stuck in 2008. Storage is where your operating system, apps, and files actually live, and over the last 70 years, it's gone through three big eras: spinning hard drives, SATA SSDs, and now NVMe, each roughly 10 times faster than the last. By the end of this lesson, when someone hands you a slow PC ticket, you'll know exactly which drive to recommend and why. Let's start with the fundamental split. An HDD is literally a mechanical device, glass platters spinning at 5400 to 7200 RPM with a read head floating nanometers above the surface. Drop it, and that's your click of death. An SSD has zero moving parts, just banks of NAND flash chips storing data as voltage. The speed gap is brutal. On random reads, the metric that actually matters for boot times, an HDD does about 1 MB/s, while an SSD does 50 to 500. That's why an SSD boots in 10 seconds and an HDD takes 2 minutes. The only place HDDs still win in 2026. Bulk cheap storage. 4 to 22 terabytes at 15 to 25 bucks per TB, perfect for backups and archives nobody touches. But here's the twist. Not all SSDs are equal, and the bottleneck often isn't the chips. It's the interface they plug into. SATA, designed back in 2003 for spinning disks, caps out at 600 megabytes per second. A ceiling we hit in 2010 and never broke. NVMe throws that out, talking directly to the CPU over PCIe lanes, 3,000 to 14,000 megabytes per second, depending on the generation. Same flash chips, different socket, 5 to 25 times the speed. And watch what that means in practice. Windows boots in 15 seconds on SATA, 8 on NVMe. A 10 gig file copy drops from 22 seconds to 3. Just remember, the motherboard and the drive both have to support the same PCI generation, or your shiny Gen 5 stick runs at Gen 3 speed. Let's put those numbers side by side because the latter tells the whole story. A spinning HDD tops out around 200 megabytes per second. SATA SSD nearly triples that to 550. Then NVMe Gen 3 leaps to 3,500. Gen 4 doubles to 7,000. And Gen 5 doubles again to 14,000. That's 70 times faster than the hard drive we started with. And here's the practical takeaway. Swapping an old HDD for even a budget SATA SSD is the single biggest "my PC feels new" upgrade you can sell a user. NVMe is the cherry on top for power users. Now here's where it gets practical. Storage shopping is always pick 2, compromise on the third. You want fast and huge? Pay up. Cheap and huge, you're back on a hard drive. Fast and cheap, keep it small. So when a ticket lands on your desk, match the drive to the roll. A 500 gig NVMe handles the office PC for 50 bucks. Gamers want a 1 terabyte NVMe. Video editors pair a fast scratch drive with a big HDD archive, and a NAS just wants 4 cheap spinning disks in RAID. The old PC revival? 1 terabyte SATA SSD, 60 bucks, instant hero. And here's the hard truth you'll repeat to users until you're blue in the face. That fast NVMe inside their laptop is one copy, not a backup. When the drive dies, and it will, those files are gone. So learn the 4 moves. An external USB drive for the quick local copy, a NAS with RAID for the always-on network backup, cloud services like Backblaze or OneDrive for the offsite layer, and the rule that ties it all together. 3 copies, 2 different media, 1 offsite. Drill that into every user you support. Now let's put it all together with 4 tickets straight off the queue. Ticket 1, slow laptop, 3-minute boot. That's an HDD 8 times out of 10. Swap in a 1 terabyte SATA SSD and clone it. 2-hour job. Ticket 2, video editor, out of space. NVMe for the OS, second NVMe for scratch, big HDD for archive. Ticket 3, lost photos, no backup. Attempt recovery, then drill 321 into them. Ticket 4, red light on the NAS. Don't panic. RAID's doing its job. Swap the drive and let it rebuild. Before we wrap, Let's lock in the vocabulary, because these 12 terms are the language you'll hear on every drive box and every ticket. Top row, HDD, SSD, NVMe, the three drive types and the whole story of this lesson. Middle row, SATA M2, PCIe, how they connect. Then RPM for spinning disks, TBW for SSD lifespan, RAID for reliability, and finally NAS for shared storage, plus sequential versus random, the marketing number versus how it actually feels. Memorize these and you're speaking junior storage tech. Now, before you walk away thinking you're an expert, let me kill 5 myths that cause real lost data. 1. SSDs do fail. Silently and suddenly, no warning clicks, so backups stay essential. 2. Never defrag an SSD, you're just burning write cycles for nothing. 3. A pricier SSD in the same tier rarely feels faster. Read the benchmarks. 4. NVMe in an old PCIe Gen 2 slot gets capped, and some old boards won't even boot from it. And 5. The sysadmin commandment. RAID is uptime, not backup. RAID won't save you from ransomware, deletes, or lightning. You need both. And that's storage locked in. 4 things to carry forward. HDDs are slow but unbeatable on cost per terabyte. SATA tops out around 600 megabytes a second. NVMe means M.2 running on PCIe lanes. And your backup strategy is 3-2-1 always. Next up, lesson 21, monitors and display. We'll break down 1080p versus 1440p versus 4K, refresh rates, panel types, and which cable, HDMI, DisplayPort, or USB-C, belongs in which port. See you there.